Hey, welcome to Peaceful Mysteries. I'm so happy you're here. I know you must be exhausted after a long day, and what better way to unwind than to join me for a cozy, calming journey into the world of Is the Brain Just Guessing the World Around You? Whether you're relaxing in bed, curling up on the couch, or simply needing a peaceful escape, you've come to the right place. But before we dive into the world of Is the Brain Just Guessing the World Around You, I'd be so grateful if you could like this video, share it with others, and subscribe to Peaceful Mysteries. It helps us grow this little corner of calm, and I truly appreciate your support. Now, let's settle in and explore the wonders of Is the Brain Just Guessing the World Around You? Today, we are diving into the fascinating world of Is the Brain Just Guessing the World Around You? We'll explore how your mind constructs the very reality you experience moment by moment, uncover the surprising truth about perception and consciousness, and walk through the incredible journey of scientific discovery that's reshaping our understanding of what it means to be human. So sit back, relax, and let's begin our gentle journey through Is the Brain Just Guessing the World Around You? Imagine for a moment that you're sitting in your favourite chair. Perhaps the one you're in right now, looking around at the familiar world that surrounds you. The walls seem solid and steady, the colours rich and vibrant, the sounds clear and distinct. Everything feels immediate, real, undeniably present. But what if I told you that this experience, this very moment you're living right now, is not quite what it seems? What if the reality you perceive is actually a sophisticated story being told by the most remarkable storyteller you'll never fully know, your own brain? This isn't the beginning of a philosophical riddle or a mystical tale, though it might sound like one. It's the startling conclusion that neuroscientists around the world have been reaching as they peer deeper into the mysteries of human consciousness and perception. The truth is both humbling and astonishing. Your brain doesn't simply receive information about the world and present it to you like a faithful camera or recording device. Instead, it's constantly engaged in an elaborate act of creative interpretation, prediction, and yes, educated guessing. Dr. Carl Friston of University College London, one of the most influential neuroscientists of our time, has spent decades studying this phenomenon. His research suggests that our brains are essentially hypothesis-testing machines, constantly generating predictions about what should be happening based on our past experiences and expectations. When you look at the world around you, your brain isn't showing you what's actually there in this precise moment. It's showing you what it expects to be there, refined and adjusted by the sensory information flowing in through your eyes, ears, and other senses. Think about the last time you caught a ball thrown to you. It seems so effortless, so natural. You see the ball coming, you extend your hand, and somehow your timing is perfect. But here's the remarkable thing. By the time the light from that ball reaches your eyes, travels to your visual cortex, gets processed, and sends signals to your muscles, the ball should have already sailed past you. The visual information your brain receives is actually hundreds of milliseconds old. Yet somehow you catch the ball with ease. The answer lies in your brain's extraordinary ability to predict the future. As researchers Christian Kaisers, Georgia Solani, and Valeria Gazzola discovered in their groundbreaking work, your brain doesn't react to what has already entered your eye. Instead, it predicts what will happen next, based on expectations and previous experiences. Your brain is essentially telling you a story about where that ball will be, not where it was when the light first hit your retina. This prediction happens so seamlessly, so automatically that you're completely unaware of it. The conscious experience feels immediate and direct, but it's actually the result of incredibly sophisticated neural calculations happening beneath the surface of your awareness. Your brain is constantly running simulations, making educated guesses about the world, and then using incoming sensory data primarily to check whether those guesses were correct. When the predictions match the incoming information, everything feels smooth and normal. But when there's a mismatch, when reality doesn't align with what your brain expected, that's when things get interesting. That's when you might experience surprise, confusion, or those fascinating moments when your perception shifts dramatically. Like when you realise the glass you thought was full of orange juice actually contains milk. To truly understand how your brain creates the reality you experience, we need to journey into the realm of what scientists call predictive processing. This isn't just a theory anymore, it's become one of the most influential frameworks in modern neuroscience, revolutionising our understanding of everything from perception to consciousness itself. Picture your brain as a vast interconnected network of prediction engines, each one specialised for different aspects of experience. The visual cortex at the back of your head isn't just passively receiving images from your eyes, it's actively generating predictions about what you should be seeing, based on patterns it has learned over your entire lifetime. The auditory regions aren't simply processing sounds, they are constantly anticipating what you should be hearing next. This predictive processing operates in a fascinating hierarchy. Higher-level brain regions, those involved in more abstract thinking and planning, send predictions downward to lower-level sensory areas. These predictions essentially tell the sensory regions what to expect. Meanwhile, the sensory areas send prediction errors upward, signals that indicate when reality doesn't match the prediction. Dr. Jakob Hohwy, author of The Predictive Mind, describes this process as the brain trying to minimize surprise. Your brain is constantly working to make the world as predictable as possible, because predictability means efficiency, and efficiency means survival. When something unexpected happens, it grabs your attention because your predictive system has encountered an error that needs to be resolved. But here's where it gets truly fascinating. Consciousness itself might be a byproduct of this predictive processing. When your brain generates predictions about what's happening in the world, it also generates predictions about what's happening within your own body and mind. The feeling of being aware, of having a continuous stream of conscious experience, might be your brain's ongoing story about its own internal states. This has profound implications for how we understand reality. Neuroscientist Andy Clark, a pioneer in predictive processing research, suggests that we're not perceiving the world directly. Instead, we're perceiving our brain's best guess about the world, a guess that's constantly being refined and updated as new information comes in. The world you experience is, in a very real sense, a controlled hallucination, a story being told by neural networks that have learned to predict the patterns of sensory input. Consider the simple act of recognizing a face. When you see someone you know, your brain doesn't laboriously analyze each feature individually. Instead, it generates a prediction about who this person might be based on subtle cues, context, and prior experience. The actual visual processing often serves mainly to confirm or adjust this prediction. This is why you might sometimes think you see a familiar face in a crowd, only to realize as you get closer that you were mistaken. Your brain was telling you a story about who that person was, and it took additional information to correct the narrative. The predictive brain also explains many of the quirks and biases in human perception. We tend to see what we expect to see, hear what we expect to hear, and even feel what we expect to feel. Our past experiences don't just influence our interpretations of new experiences, they actually shape the perceptions themselves at the most fundamental level. This predictive processing isn't limited to basic sensory experiences. Your brain is also constantly making predictions about other people's actions, emotions, and intentions. When you watch someone reaching for a glass of water, your brain activates many of the same neural circuits that would be active if you were reaching for the glass yourself. This might be the neurological basis of empathy, our ability to understand and share the feelings of others. Now, let's explore one of the most fascinating ways to peek behind the curtain of perception: optical illusions. These aren't just clever tricks or entertaining diversions, they're windows into the fundamental nature of how your brain constructs reality, revealing the surprising truth that what you see is not always what's actually there. Consider the phenomenon of your blind spot, a place in each eye where the optic nerve connects to the retina and no photoreceptors exist. By all rights, you should perceive a black hole in your vision, a gap in the world around you. But you don't. Your brain seamlessly fills in this gap using information from the surrounding area in your other eye. You're completely unaware that this filling in process is happening, yet it's occurring every moment you're awake. Recent research has shown that this filling in process is remarkably sophisticated. Scientists can now map the activity in early visual cortex areas and see exactly how the brain manufactures visual information for the blind spot region. What's most astonishing is that people often treat these filled-in percepts as more real and reliable than actual visual information. Your brain's guess about what should be in the blind spot can feel more certain to you than what you're actually seeing in other parts of your visual field. But the blind spot is just the beginning. There are countless ways your brain creates visual experiences that don't correspond to the actual light patterns hitting your eyes. Take the checker, shadow, illusion, a classic demonstration created by vision scientist Edward Adelson. In this illusion, two squares that appear to be dramatically different shades of grey are actually identical. One square appears to be in shadow surrounded by darker tiles, while the other seems to be in bright light. Your brain, taking into account the apparent lighting conditions, decides that the square in shadow must be lighter than it actually is. This isn't a failure of your visual system, it's actually a testament to its sophistication. Your brain is trying to tell you about the true colour of objects in the world, not just the wavelengths of light currently reaching your eyes. If your eyes functioned like scientific instruments, simply measuring wavelengths, they would constantly be fooled by changing lighting conditions. A white shirt would appear red under red light, blue under blue light. Instead, your brain performs complex calculations to try to determine what colour objects actually are, independent of the lighting conditions. Sometimes these calculations go awry, creating the illusions that reveal so much about how perception works. The dress that broke the internet in 2015 is a perfect example. Some people saw it as blue and black, others as white and gold. Pascal Wallisch, a neuroscientist at New York University, discovered that this difference in perception correlated with people's sleep patterns. Night owls were more likely to see the dress as blue and black, while early risers tended to see it as white and gold. Wallisch's explanation is elegant. People who spend more time in natural daylight versus artificial lighting have different assumptions about the lighting conditions in the ambiguous photograph. Their brains filter out what they expect the lighting to be, leading to different perceptions of the dress's actual colour. The remarkable thing is that these assumptions operate completely below the level of consciousness. Your brain doesn't tell you, "I'm adjusting for what I think the lighting conditions are." It simply presents you with what it's determined the colours to be. Motion illusions reveal another layer of your brain's predictive processing. In the flash lag illusion, a moving dot and a flashing dot that are perfectly aligned appear misaligned. The moving dot seems to be ahead of the flashing dot. This happens because your brain predicts where moving objects will be by the time you finish processing the visual information. For stationary objects, there's no prediction needed, so they appear exactly where the delayed visual processing shows them to be. These illusions aren't accidents or glitches. They're the inevitable result of a visual system that has evolved to be fast, efficient, and predictive rather than perfectly accurate. Patrick Kavanagh, a vision scientist at Dartmouth College, puts it beautifully. We're not seeing reality, we're seeing a story that's being created for us. This story is usually so compelling and consistent that we never question it. But illusions give us glimpses of the storytelling process itself. The more we understand about perception and consciousness, the more we realise that your brain is fundamentally a storytelling organ. It's not content simply to present you with raw sensory data. Instead, it weaves that data into coherent narratives about the world, about other people, and about yourself. These stories feel so real, so immediate, that it's almost impossible to believe they're constructions rather than direct experiences of reality. But the evidence for this storytelling view of consciousness keeps mounting. Consider what happens when you look at an ambiguous image, like the famous drawing that can be seen as either a vase or two faces in profile. Your perception flips back and forth between these two interpretations, even though the image itself never changes. What's happening is that your brain is trying out different stories about what the image represents, settling on one for a while before switching to another. This storytelling process extends far beyond visual perception. Your brain is constantly constructing narratives about the intentions and emotions of other people. When you see someone's facial expression, you don't just register the position of their eyebrows and the curve of their mouth. Your brain instantly generates a story about what that person is feeling, thinking, and likely to do next. These stories feel like direct perceptions, but they're actually sophisticated inferences based on subtle cues and your past experiences with human behavior. Remarkably, your brain uses many of the same neural circuits to understand others' actions that it uses to control your own actions. When you watch someone reaching for a cup, neurons in your motor cortex become active as if you were reaching for the cup yourself. This neural mirroring might be the biological basis of empathy, allowing you to understand others by simulating their experiences in your own brain. The predictive nature of this process becomes clear when you consider how we respond to unexpected events. Imagine watching someone lift what appears to be a full carton of milk, only to see it fly upward much faster than expected, because it's actually empty. You feel surprised, even though you're not the one doing the lifting. Your brain had generated a prediction about how the lifting should look based on your own experiences with full milk cartons. When reality violates this prediction, you experience surprise. Memory too is part of this storytelling process. Your brain doesn't store memories like files on a computer. Instead, it reconstructs memories each time you recall them, filling in gaps and adjusting details based on your current knowledge and expectations. This is why eyewitness testimony can be so unreliable, why siblings can have dramatically different memories of the same childhood events, and why your memories of past experiences can change over time. Elizabeth Loftus, a pioneering memory researcher, has shown how easily false memories can be implanted through suggestion. People can develop vivid, detailed memories of events that never happened, complete with emotional responses and sensory details. These false memories don't feel false to the people experiencing them. They feel every bit as real as genuine memories because they're constructed using the same neural processes. The stories your brain tells about your own body are equally fascinating. The rubber hand illusion demonstrates this beautifully. If you hide one of your hands and watch a rubber hand being stroked, while your hidden hand receives the same stroking, you can actually begin to feel as if the rubber hand is your own hand. Your brain, receiving synchronized visual and tactile information, constructs a story that incorporates the rubber hand into your body schema. This illusion reveals the plasticity of our sense of embodiment. What feels like a fixed, unchanging awareness of your body's boundaries is actually a dynamic construction that can be altered by the right combination of sensory experiences. Some researchers believe that understanding these processes might help develop better prosthetic devices or treatments for conditions where body perception is disrupted. The storytelling view of consciousness has profound implications for how we understand ourselves and our place in the world. If our perceptions, memories, and sense of self are all constructions rather than direct reflections of reality, then perhaps the rigid certainty we often feel about our experiences is misplaced. This doesn't mean we can't trust our senses or that reality is entirely subjective. It means that our brains are doing incredibly sophisticated work to present us with coherent, useful interpretations of a complex world. The remarkable thing is that these stories are usually very good. Your brain's predictions about the world are accurate enough to let you navigate complex environments, catch flying balls, recognize faces, and understand the intentions of others. The system works so well that most of the time you're completely unaware that any storytelling is happening at all. It's only when the stories break down, in illusions or unusual circumstances, that we catch glimpses of the construction process itself. As we continue our journey into understanding how the brain creates reality, we'll explore even more surprising aspects of this process. We'll discover how your expectations literally shape what you perceive, how your brain fills in not just missing visual information, but missing time itself, and how consciousness might be the ultimate story your brain tells about its own activity. The world as you experience it is far stranger and more wonderful than it appears on the surface. Now, let's step into the magic theatre of your own eyes, where the most extraordinary show happens every single moment of your waking life. Imagine, if you will, that you're sitting in a comfortable chair in a dimly lit theatre, watching a performance that's been running continuously since the day you were born. The performers on this stage are light waves, shadows, colours and shapes, all dancing together to create what you believe is reality. But here's the beautiful secret that neuroscientists have recently discovered. You're not just watching this show passively. Your brain is the director, the scriptwriter, and sometimes even the magician, creating illusions so convincing that you never question what you're seeing. Picture yourself walking through a sun-dappled forest path where light filters through the canopy above, creating shifting patterns of brightness and shadow onto the ground before you. As you walk, your eyes are constantly taking in thousands of pieces of visual information every second, yet somehow the world appears stable, coherent, and beautifully unified. This is your brain's first magic trick, and it's one that happens so seamlessly you never even notice it. Your visual system isn't simply recording what's out there like a camera would. Instead, it's actively constructing a version of reality based on educated guesses, past experiences, and a sophisticated prediction system that would make any fortune teller envious. Let's begin with one of the most fascinating discoveries about how your eyes actually work. Right now, as you're reading these words, there's a part of your visual field where you're completely blind, yet you never notice it. This isn't a malfunction or a problem with your eyes, it's simply how they're designed. Deep within each of your eyes, there's a spot where your optic nerve connects to your retina, the light-sensitive layer at the back of your eye. At this connection point, there are no light-detecting cells, creating what scientists call the physiological blind spot. The remarkable thing about this blind spot isn't that it exists, but that you never see it. Right now, there's a black hole in your vision, roughly the size of 9 full moons placed side by side, yet your brain fills it in so perfectly that you're completely unaware of it. This happens through a process that scientists are only beginning to understand. Your brain looks at all the visual information surrounding your blind spot and makes an intelligent guess about what should be there. If you're looking at a wall covered in blue wallpaper with small white flowers, your brain will paint that same pattern into your blind spot. If you're gazing at a clear blue sky, your brain fills in more blue sky. Recent research published in 2024 has revealed that this filling-in process is far more sophisticated than anyone previously imagined. Using advanced brain imaging techniques, neuroscientists at leading universities have discovered that your brain doesn't just paste a simple pattern into your blind spot. Instead, it engages in what they call hierarchical predictive coding, analysing the complex patterns, textures and relationships in your visual field and then generating the most likely continuation of those patterns to fill in the gap. It's like having a master artist in your head who can perfectly match any wallpaper pattern or continue any landscape seamlessly. But your brain's artistic talents don't stop there. Every single day you experience dozens of visual illusions without even realising it. These aren't party tricks or curiosities. They're glimpses into the fundamental way your visual system operates. Consider the way shadows work in your everyday experience. When you see a white piece of paper lying in shadow, it actually reflects less light to your eyes than a piece of charcoal sitting in bright sunlight. Yet you never confuse the paper for charcoal. Your brain automatically adjusts for the lighting conditions, making assumptions about what colour objects really are based on the context around them. This process of colour constancy reveals something profound about perception. Your brain isn't measuring the actual wavelengths of light hitting your eyes with scientific precision. Instead, it is telling you a story about colour, a story that is useful for navigating the world but isn't always accurate. When you look at a red apple, what you're experiencing as red is your brain's interpretation of certain wavelengths of light, filtered through assumptions about lighting conditions, influenced by the colours of surrounding objects, and shaped by every red thing you've ever seen in your life. Deeper in the theatre of your mind, there's another performance happening that's even more astounding. Your brain is constantly playing a guessing game with time itself, predicting what you're about to see before you actually see it. This might sound like science fiction, but it's actually a necessary adaptation that evolution gifted to every creature with eyes. You see, there's a dirty little secret about your visual system that most people never learn. Everything you see happened in the past. When light from the world around you enters your eyes, it takes time to be converted into electrical signals, then more time for those signals to travel through your optic nerves to your visual cortex, and even more time for your brain to process and interpret those signals. All told, what you think you're seeing right now actually happened about 100 to 200 milliseconds ago. In the time it takes for you to process what you're seeing, a baseball pitcher's fastball could travel several feet, a hummingbird could flap its wings multiple times, or a child running toward you could take several more steps. If your brain simply showed you this delayed information, you'd be living in the past, always reacting too late to catch that ball, swat that fly, or respond to that child's approach. So your visual system does something extraordinary. It predicts the future. Based on patterns of movement it detects, your brain calculates where moving objects should be by the time you're actually seeing them, and presents you with this predicted version of reality instead of the delayed actual version. Scientists have discovered this prediction system through clever experiments that reveal the brain's time-travelling abilities. One of the most elegant demonstrations is called the flash lag illusion. Imagine watching a red dot moving across a screen from left to right at a steady pace. At some point during its journey, a green dot flashes briefly at the exact same location as the red dot. Even though both dots occupy the same position at the same time, the red dot appears to be ahead of the green dot. Your brain, anticipating where the red dot should be by the time you process the visual information, shows you the predicted future position rather than the actual past position. This predictive system works so well that you never notice it operating. When you reach out to catch a ball, your hand moves to where your brain predicts the ball will be, not where your eyes see it at that moment. When you pour milk into your coffee cup, your brain coordinates your movements based on predictions about how the liquid will flow and where the cup will be when the milk reaches it. Every smooth, coordinated movement you make depends on your brain's ability to see into the future to guess what reality will look like a split second from now. Like any prediction system, your brain's visual forecasting can sometimes get it wrong, and these mistakes create some of the most beautiful and puzzling optical illusions. Consider the rotating snake illusion, where a still image appears to writhe and move even though nothing on the page is actually moving. Your brain, detecting subtle patterns in the contrast and positioning of the elements in the image, predicts that movement should be occurring and generates the sensation of motion even though your eyes are reporting that everything is stationary. Research conducted in 2024 at leading neuroscience laboratories has revealed that these prediction errors don't just happen in vision. They're fundamental to how your entire brain operates. Using advanced brain imaging techniques, scientists can now watch in real time as your brain generates predictions about what should happen next, compares those predictions to what actually happens, and updates its models when the predictions are wrong. This process, called prediction error minimization, appears to be one of the core computational principles that makes consciousness possible. Let's venture deeper into this mysterious landscape of perception, where your brain builds an entire world from fragments and assumptions. Imagine your visual system as a master architect, but one who never gets to see the complete blueprints. Instead, this architect must design and build a coherent structure based on partial information, educated guesses, and a lifetime of construction experience. The result is the rich, detailed, seemingly complete visual world you experience every moment, constructed from surprisingly sparse and ambiguous information. Your eyes, remarkable as they are, actually provide your brain with far less information than you might think. The only part of your visual field where you can see fine details is a tiny area called the fovea, roughly the size of your thumbnail held at arm's length. Everything else in your peripheral vision is surprisingly blurry and lacking in detail. Yet right now, as you sit reading, you feel as though you can see your entire surroundings clearly. This is another of your brain's magnificent illusions. It's taking the detailed information from wherever you're looking and using that to make assumptions about everything else. This process becomes beautifully apparent when you consider how your brain handles the constant dance of your eyes. Your eyes don't move smoothly across a scene like a video camera panning across a landscape. Instead, they make rapid, jerky movements called saccades, jumping from point to point several times per second. During each of these jumps, which last about 20 to 40 milliseconds, you're effectively blind. Your brain simply turns off visual processing during the movement to avoid the blur and confusion that would result from trying to process a rapidly moving image. But here's the remarkable part. You never notice these brief moments of blindness. Your brain seamlessly stitches together the snapshots from each fixation point, creating the illusion of continuous smooth vision. It's like watching a movie where every 20th frame has been removed, but your brain fills in the gaps so perfectly that you never notice the missing pieces. This process, called saccadic masking, reveals how much of what you experience as seeing is actually remembering and predicting rather than direct sensory input. Recent discoveries in neuroscience have revealed that this constructive process extends far beyond simple gap filling. Your brain maintains what researchers call a predictive model of your visual environment, essentially a continuously updated three-dimensional map of everything around you. This model includes not just what you can currently see, but predictions about what lies beyond your current field of view, what objects might be hidden behind others, and how the scene will change as you or other objects move through it. This predictive modelling becomes especially fascinating when we consider how your brain handles occlusion, objects blocking other objects from view. When you see a person walking behind a tree disappearing from view for a moment before emerging on the other side, your brain doesn't simply lose track of them during the hidden portion of their journey. Instead, it maintains a prediction about where they should be and when they should reappear, allowing you to track their movement even when you can't see them. This is why it feels surprising if someone emerges from behind an obstruction at an unexpected time or location. Your brain's prediction was violated. The sophistication of this system becomes even more impressive when you realize that it's constantly dealing with ambiguity. The pattern of light hitting your retinas could potentially correspond to countless different three-dimensional arrangements of objects in the world. A small nearby object casts the same size image on your retina as a large distant object. A bright object in shadow might reflect the same amount of light as a dark object in bright light. Yet your brain resolves these ambiguities so quickly and confidently that you rarely even notice they exist. To handle this ambiguity, your brain relies on what scientists call priors, assumptions based on your past experience about how the world usually works. These priors are like a vast library of visual knowledge that your brain has accumulated throughout your lifetime. They include assumptions like light usually comes from above, objects are usually illuminated evenly, things that look similar are usually similar, and thousands of other statistical regularities about the visual world. In the most fascinating wing of your brain's visual museum, there's a gallery dedicated to impossible things, images and experiences that reveal just how creative and sometimes mistaken your visual system can be. These optical illusions aren't mere curiosities or party tricks, they're windows into the deepest principles of how your mind constructs reality. Each illusion tells a story about the assumptions, shortcuts, and creative interpretations that your brain uses every moment of every day. One of the most revealing illusions involves something as simple as brightness. Look at any checkerboard pattern, where squares alternate between light and dark. Now imagine that a shadow falls across part of this checkerboard. In the shadowed area, what appears to be a light square might actually be reflecting the same amount of light as what appears to be a dark square in the bright area. Your brain, knowing that shadows darken everything they touch, automatically adjusts its interpretation of brightness. It tells you a story about what colours the squares really are, separate from the lighting conditions affecting them. This brightness constancy reveals something profound. Your brain is not a light meter measuring the actual photons hitting your eyes. Instead, it's a storyteller, interpreting those photons and weaving them into a narrative about surfaces, materials and lighting that makes sense of the world. Sometimes this storytelling leads you to see things that aren't quite as they seem. But most of the time, it allows you to navigate a complex visual world with remarkable accuracy and efficiency. Colour provides another window into your brain's creative interpretation of reality. The colours you see don't exist out there, in the world. They exist only in your mind. What exists in the external world are electromagnetic waves of different frequencies. Your brain takes these invisible waves and transforms them into the rich palette of reds, blues, greens, and every other hue you've ever experienced. This transformation is so fundamental to your experience that it's almost impossible to imagine what the world would be like without it. But your brain's colour creation system can be fooled in beautiful ways. Consider what happens when you stare at a red square for 30 seconds and then look at a white wall. You'll see a ghostly green square floating on the wall, a colour that isn't there, created entirely by your visual system. This afterimage occurs because the cells in your eyes that respond to red light become fatigued from prolonged exposure. When you look at the white wall, these fatigued cells respond more weakly than the cells that detect green light, creating an imbalance that your brain interprets as green. Recent research has revealed that colour illusions can be far more sophisticated than simple afterimages. Scientists have discovered that your perception of colour depends heavily on context. The same wavelength of light can appear to be completely different colours depending on what surrounds it. This context dependency means that your brain is constantly making assumptions about lighting conditions, surface properties, and the relationships between different coloured regions of your visual field. Perhaps the most famous example of this contextual colour processing emerged from a simple photograph of a dress posted on social media. Some people saw the dress as blue and black, while others saw it as white and gold. This wasn't a matter of opinion or preference. People were literally seeing different colours when looking at the same image. Neuroscientists eventually determined that the difference came down to assumptions about lighting. People who assumed the dress was photographed in bright daylight filtered out blue wavelengths and saw white and gold. Those who assumed indoor artificial lighting filtered differently and saw blue and black. This dress phenomenon revealed something remarkable about individual differences in perception. Your lifetime of visual experiences shapes the assumptions your brain makes about new images. If you've spent more time in natural daylight, you might be more likely to assume daylight illumination when viewing an ambiguous image. If you're more familiar with artificial indoor lighting, you might default to those assumptions instead. In this way, your personal history literally changes what you see. Motion provides yet another realm where your brain's predictive storytelling creates fascinating illusions. There are static images that appear to move, moving objects that appear stationary, and movements that seem to happen in impossible directions. Each of these illusions reveals something about how your brain processes the complex task of detecting and interpreting movement in a three-dimensional world. One particularly elegant motion illusion involves what appears to be a moving object casting a shadow. As the object moves across the screen, its shadow moves along the ground beneath it. But here's the fascinating part. If you cover up the moving object and only watch the shadow appears to slow down dramatically. Your brain, seeing both the object and its shadow, assumes they should move together and adjusts your perception of the shadow's speed to match what it expects. When you remove this context by covering the object, the shadow's actual speed becomes apparent. These discoveries about motion processing have revealed that your brain doesn't just passively record movement. It actively constructs movement based on expectations, context, and predictions about how objects should behave in the physical world. Your visual system is constantly solving complex physics problems, calculating trajectories, predicting collisions, and estimating the forces and constraints that govern how objects move through space. Picture, if you will, a grand theatre in your mind. Not the kind with velvet seats and golden balconies, but something far more mysterious and beautiful. This is your memory theatre, where every experience you've ever had is supposedly stored, waiting to be called back to the stage of your consciousness. But here's where our gentle journey takes a fascinating turn, dear friend. This theatre doesn't work quite the way you might imagine. For centuries we've thought of memory like a vast library, with each experience carefully catalogued and filed away, ready to be retrieved exactly as it happened. We imagined our brains as perfect recording devices, capturing life's moments with the precision of a camera. Dr. Elizabeth Loftus, one of the world's leading memory researchers, spent decades discovering just how wonderfully wrong this assumption was. Her work revealed something that might surprise you. Your memory theatre doesn't just store experiences, it actively rewrites them, embellishes them, and sometimes creates entirely new performances that never happened at all. Think about your earliest childhood memory for a moment. Can you see it clearly? Perhaps it's your third birthday party, or the first day of school, or a family vacation to the beach. Now, here's something that might give you pause. Neuroscientists have discovered that what you're remembering isn't actually the original experience. Instead, you're remembering the last time you remembered it. Each time you recall that cherished memory, your brain reconstructs it, and in that reconstruction, tiny changes creep in. It's like a story that changes slightly each time it's told, until after many retellings, it bears only a passing resemblance to the original tale. Your predictive brain doesn't just guess about the future you see, it also makes educated guesses about the past. When you try to remember something, your brain gathers fragments, pieces of sensory information, emotions and context clues, then weaves them together into what feels like a coherent memory. But just as your brain fills in your blind spot without you realizing it, it also fills in the gaps in your memories with information that seems to fit, that makes the story complete and meaningful. Dr. Loftus conducted a particularly revealing experiment that demonstrates this beautifully. She showed people videos of car accidents, then asked them questions about what they saw. But here's the clever part, she varied the words she used in her questions. When she asked, how fast were the cars going when they smashed into each other? People reported much higher speeds than when she asked, how fast were the cars going when they contacted each other? The word smashed created an expectation of violence and speed that actually changed what people remembered seeing. Even more remarkably, when she brought the same people back a week later and asked if they saw broken glass in the video, those who had heard smashed were much more likely to report seeing glass, even though there was no broken glass in the original video at all. This isn't a failure of your memory system, dear listener. It's actually a feature, not a bug. Your predictive brain is trying to create coherent, meaningful narratives from the chaos of experience. It's attempting to make sense of your life story, to find patterns and connections that help you navigate the world more effectively. When you remember your childhood birthday party, your brain isn't just retrieving data, it's constructing a story that fits with everything else you know about yourself, your family, and your past. Consider how this works in your daily life. When someone tells you about their day, and later you recount their story to someone else, you don't just repeat their words verbatim, you translate their experience through your own understanding, your own vocabulary, your own emotional framework. You might emphasize different details, interpret their tone differently, or connect their story to similar experiences you've had. In essence, you're not just passing along information, you're predicting what their experience meant and sharing that prediction. The same thing happens within your own mind. Each memory is a prediction about what probably happened, based on fragments of actual experience mixed with your beliefs, expectations, and understanding of how the world works. Your brain is constantly asking itself, given what I know about myself, about the situation, about how life generally unfolds, what most likely happened here. And then it constructs a memory that answers that question. This process becomes even more fascinating when we consider how cultural and social contexts shape our memory theatre. The stories your family tells, the historical narratives you've learned, the movies you've watched, and the books you've read all provide templates that your brain uses when constructing memories. If you grew up hearing stories about brave ancestors, you might remember your own moments of courage more vividly and in greater detail. If you've been surrounded by narratives about overcoming adversity, you might construct memories of your own challenges in ways that emphasize your resilience and growth. Now, let's explore one of the most unsettling discoveries about our memory theatre. Sometimes it stages completely fictional performances that feel absolutely real. These are what researchers call false memories, and they're far more common than you might imagine. In fact, you almost certainly have false memories that you'd swear are true. Memories that feel as vivid and real as any genuine experience you've ever had. Dr. Dan Simons, a cognitive scientist at the University of Illinois, discovered this in a rather dramatic way. He conducted what's now known as the Lost in the Mall study, where researchers convinced adults that they had been lost in a shopping mall as children, even though this had never actually happened. They did this by enlisting family members to provide details about the person's childhood, then crafting a plausible but entirely false story about getting lost. Remarkably, about 25% of participants not only believed this fictional memory, but began to elaborate on it, adding details about what they saw, how they felt, and how they were eventually found. These weren't gullible people or individuals with poor memories. They were ordinary adults with normal cognitive abilities. But their predictive brains, when presented with a story that seemed to fit with their family history and personal narrative, began to construct vivid false memories that felt completely authentic. Some participants became emotional when recounting these fictional experiences, demonstrating just how real false memories can feel. This phenomenon reveals something profound about how your memory theatre operates. Your brain doesn't distinguish between memories of actual experiences and memories of imagined experiences in the way you might expect. When you vividly imagine something, especially repeatedly, your brain creates neural pathways that are remarkably similar to those created by actual experiences. Over time, these imagined events can transform into memories that feel just as real as anything that actually happened to you. Think about this for a moment. How many times have you told a story about something that happened to you, and with each telling you've added a little detail here, emphasized a different aspect there, perhaps exaggerated slightly for effect? Each time you do this, you're not just sharing a memory, you're reshaping it. Your brain takes note of these embellishments, and slowly the embellished version becomes the real memory. The line between what happened and what you've said happened begins to blur until it disappears entirely. This process is particularly evident in family stories. Perhaps you've heard relatives tell the same story about a family event over the years, but you've noticed that the details change with each telling. Maybe the fish that Uncle Bob caught gets a little bigger each time, or the storm that Grandma weathered becomes a little more dramatic. Eventually, these enhanced versions become the family's official memory of what happened, even though the original event was likely much more ordinary. But false memories aren't just about family stories or childhood experiences. They're being created in your mind all the time, in small and large ways. Every time you read a news article and then later remember it, you're likely mixing up details from different sources, combining information you read with assumptions you made, or blending factual reporting with opinion pieces you've encountered. Your predictive brain doesn't carefully segregate information by source. Instead, it creates coherent narratives that make sense given your understanding of the world. Dr. Lynn Nadell, a neuroscientist at the University of Arizona, discovered that this process is actually essential to how memory works. He found that memories aren't stored as complete, unchanging records, but rather as networks of associated information that get reassembled each time you remember something. This process, called memory reconsolidation, means that every act of remembering is also an act of creating. You're not just accessing a file. You're writing a new version of that file based on your current knowledge, emotional state, and the context in which you're remembering. This has profound implications for how you understand your own life story. The narrative you tell yourself about who you are, where you came from, and what has shaped you is not a factual record, but rather a constantly evolving prediction about your identity. Your brain continuously updates this personal narrative, emphasizing experiences that support your current self-understanding while downplaying or even forgetting events that don't fit the story you've constructed about yourself. For instance, if you see yourself as someone who has overcome significant challenges, you might remember difficult periods in your life with greater clarity and detail than happy, uneventful times. Your brain is predicting that these challenging experiences are the most important parts of your story, so it makes them more memorable and emotionally vivid. Conversely, if you identify as someone who's been fortunate and blessed, you might have richer, more detailed memories of positive experiences while the difficulties fade into the background. This isn't conscious deception or self-delusion. It's your predictive brain working exactly as it's designed to work, creating coherent narratives that help you maintain a stable sense of identity and purpose. But it does mean that your memory theatre is more like a creative performance space than a documentary archive. Each memory is a production, complete with interpretation, emotional colouring and artistic license. As we settle deeper into our exploration of the memory theatre, let's consider perhaps the most beautiful and complex performance that takes place on its stage: the story you tell yourself about who you are. This grand narrative, woven from threads of memory, prediction and imagination, shapes not just how you remember your past, but how you experience your present and envision your future. Your sense of self, that continuous feeling of being you across time and changing circumstances, is one of your brain's most sophisticated predictions. Think about it. The physical matter of your body replaces itself entirely every 7 years or so. Your thoughts, knowledge and experiences are constantly evolving. Your circumstances, relationships, and environment are always changing. Yet somehow, you maintain a coherent sense of being the same person who existed yesterday, last year, and in your earliest memories. This continuity is largely an illusion created by your predictive brain's storytelling abilities. Dr. Antonio Damasio, a renowned neuroscientist at the University of Southern California, describes this as the autobiographical self, a constantly updated narrative that your brain constructs to make sense of the stream of experiences that make up your life. This story isn't stored somewhere in your brain like a book on a shelf. Instead, it's recreated moment by moment, each time slightly different, adapted to your current situation and understanding. Consider how this works when you introduce yourself to someone new. You don't simply list facts about your life. You curate a particular version of your story, emphasizing certain experiences while glossing over others, presenting yourself in a way that makes sense for this particular context. But here's what's fascinating. In the process of telling your story, you're also reinforcing it for yourself. Each time you share certain aspects of your experience, you're strengthening the neural pathways associated with those memories, making them more likely to be part of your self-narrative in the future. This process of self-construction through storytelling happens not just in conversations with others, but in the constant internal dialogue you have with yourself. Throughout the day, your brain is continually predicting not just what will happen next in the external world, but what kind of person you are and how you're likely to respond to different situations. These predictions then influence your actual behaviour, creating a feedback loop where your beliefs about yourself help determine who you become. Dr. Timothy Wilson, a social psychologist at the University of Virginia, has conducted fascinating research on what he calls story editing, the process by which people can literally change their life trajectories by changing the stories they tell about themselves. In one study, he worked with college students who were struggling academically. Rather than focusing on study skills or time management, He simply provided them with information suggesting that academic difficulties in the first year of college were normal and temporary, rather than indicative of a lack of ability. This simple reframing, this slight edit to their personal narratives, had remarkable effects. Students who received this intervention not only improved their grades, but were less likely to drop out of college entirely. They had changed their predictions about themselves from "I'm probably not cut out for this" to "this is a temporary challenge that I can overcome." This shift in self-narrative actually changed their behaviour and ultimately their reality. Your brain's tendency to create coherent narratives extends beyond your personal story to encompass your understanding of other people and the world around you. When you meet someone new, you don't just observe their behaviour objectively. You immediately begin constructing a story about who they are, what motivates them, and how they're likely to act in different situations. These predictions then influence how you interact with them, often in ways that actually encourage them to fulfill your expectations. This process, known as the confirmation bias, is your predictive brain's way of maintaining consistency in your worldview. Once you've constructed a narrative about someone or something, you naturally pay more attention to information that confirms your story while overlooking or downplaying evidence that contradicts it. It's not that you're being dishonest or close-minded. It's that your brain is trying to maintain coherent, useful predictions about the world. But here's where the story becomes even more intriguing. Your narrative about yourself and others isn't just influenced by your direct experiences. It's also shaped by the countless stories you've encountered throughout your life, in books, movies, family tales, cultural myths, and social media posts. Your brain uses these narrative templates as a kind of library when constructing your personal story, borrowing plot structures, character archetypes, and thematic elements that resonate with your experiences. If you've grown up surrounded by stories of transformation and redemption, you're more likely to interpret your own struggles as part of a heroic journey towards growth and wisdom. If the narratives you've encountered emphasize the importance of community and connection, you might construct memories that highlight the relationships and social bonds in your life. Your personal story isn't created in isolation. It's co-authored by your culture, your family, your community, and the broader human story of which you're a part. This cultural dimension of memory and self-narrative helps explain why people from different backgrounds can have such different interpretations of the same events. It's not just that they have different opinions. They're literally constructing different realities based on different narrative frameworks. When someone from a culture that emphasizes individual achievement encounters a setback, they might remember it as a personal failing that needs to be overcome through harder work. Someone from a culture that emphasizes collective support might remember the same setback as evidence of the need for stronger community bonds. Dr. Chi Wang, a developmental psychologist at Cornell University, has studied how cultural backgrounds influence autobiographical memory. She found that people from individualistic cultures tend to have more detailed, emotionally elaborate memories of personal experiences, while people from collectivistic cultures have memories that are more focused on social relationships and group harmony. These aren't just different ways of talking about memories. They represent fundamentally different ways of constructing personal narratives and, by extension, different ways of being in the world. As we near the end of this particular chapter in our journey, it's worth reflecting on what all of this means for how you understand your own life. Your memories, your sense of self, and your predictions about the future are not objective realities, but rather creative constructions of your ever-active storytelling brain. This doesn't make them less valuable or meaningful. In many ways, it makes them more so. Your personal narrative is not just a passive record of what has happened to you, it's an active force that shapes what happens next. The story you tell yourself about who you are becomes the foundation for the story you live going forward. When you understand this, you realize that you have more agency in authoring your life than you might have imagined. You can't change the facts of what has happened to you, but you can change the story you tell about those facts. You can edit your narrative, emphasize different themes, and imagine different possibilities for future chapters. This realization is both liberating and humbling. It's liberating because it suggests that you're not simply the product of your past experiences, but rather the author of an ongoing story that can evolve and change. It's humbling because it reminds you that everyone else is also living within their own constructed narrative, doing their best to make sense of their experiences and maintain a coherent sense of self in an uncertain world. Your memory theatre, with all its creative reconstructions and fictional performances, isn't a bug in the system of human consciousness. It's the very mechanism by which you create meaning, maintain identity, and navigate the complex social world in which you live. It's the stage on which the grand performance of your life unfolds, complete with all the drama, comedy, mystery, and romance that make existence not just survivable, but truly worth living. As we drift deeper into the mysteries of how your brain creates reality, we encounter something truly remarkable about the most intimate aspect of your existence, your sense of being in your own body. Right now, as you settle into this moment, you might feel the weight of your head against a pillow, or the sensation of your hands holding this device. But what if I told you that even this most basic feeling, the feeling of being you in your body, is another story your brain tells itself? The boundary between where you end and the world begins isn't as clear-cut as it seems. Your brain doesn't simply receive signals from your body and translate them into sensations. Instead, it weaves together predictions about what your body should feel like, constantly updating its model of where you are in space and what belongs to you. This process is so seamless, so automatic, that we rarely question it. Yet neuroscientists have discovered that this sense of bodily self can be surprisingly fragile and malleable. Consider for a moment the remarkable feat your brain performs every time you reach for something. Your arm moves through space, guided not just by what you see, but by an internal map your brain maintains of where your limbs are positioned. This map, called proprioception, combines signals from your muscles, joints, and inner ear with visual information to create a constantly updating sense of your body's position in space. But this map isn't perfect. It's a prediction, subject to the same biases and errors as all the other stories your brain tells. Scientists have discovered that your brain's representation of your body is surprisingly plastic. Phantom limb syndrome, experienced by people who have lost limbs, reveals that the brain's body map can persist even when the physical body part is gone. Conversely, conditions like neglect syndrome show us that brain damage can cause people to lose awareness of entire sides of their body. These phenomena tell us something profound about the nature of self-awareness. Even your sense of having a body is a construction of your predictive brain. The implications stretch far beyond medical curiosities. Every day, your brain makes countless predictions about how your body should feel as you move through the world. When you walk upstairs, your brain predicts the resistance your muscles will encounter and adjusts your movements accordingly. When you pick up a coffee cup, your brain estimates its weight and coordinates the precise grip strength needed. These predictions happen so quickly and smoothly that we're rarely aware of them, yet they form the foundation of our physical existence in the world. But what happens when these predictions go wrong? Sometimes the mismatch between expectation and reality creates those odd moments of stumbling when you think there's one more step than there actually is, or nearly dropping something that's lighter than expected. These small failures of prediction reveal the normally invisible process by which your brain constructs your bodily experience moment by moment. The story becomes even more intriguing when we consider how your brain distinguishes between sensations caused by your own movements and those caused by the external world. When you touch your own arm, the sensation feels different from when someone else touches you in exactly the same way. Your brain uses its predictions about your intended movements to dampen the sensations they create, allowing you to focus on the unexpected, the touch from outside that might signal danger or opportunity. This predictive dampening explains why you can't tickle yourself. Your brain knows what your fingers are about to do and cancels out the sensation before it reaches your conscious awareness. But when someone else's fingers create the same movements, the element of unpredictability allows the full sensation to bloom into consciousness. It's a beautiful example of how prediction shapes even the most basic aspects of bodily experience. In laboratories around the world, neuroscientists have been conducting a simple, yet profound experiment that reveals just how flexible our sense of bodily ownership really is. Picture yourself sitting at a table with your left hand hidden from view behind a small screen. In front of you, clearly visible, lies a rubber hand positioned where your real hand might naturally rest. A researcher begins to stroke both your hidden real hand and the visible rubber hand with identical brushes in perfect synchrony. At first, you're fully aware that the rubber hand isn't yours. It's obviously fake, obviously separate from your body. But as the synchronized stroking continues, stroke after stroke, sensation after sensation, something remarkable begins to happen. Slowly, almost imperceptibly, your brain starts to accept the rubber hand as part of you. You begin to feel the brush strokes on the rubber hand as if they were happening to your own flesh. The boundary between self and not self, usually so clear and fixed, begins to blur. This is the rubber hand illusion, and it reveals something profound about how your brain decides what is and isn't part of your body. Your sense of bodily ownership isn't hardwired or permanent. It's a constantly updated prediction based on the patterns of sensory information your brain receives. When visual information about the rubber hand perfectly matches the tactile sensations from your real hand, your predictive brain finds it more efficient to incorporate the rubber hand into its body model than to maintain the disconnect. The illusion can become so compelling that people will instinctively withdraw their real hand when researchers threaten the rubber hand with a hammer. Their brain, having accepted the rubber hand as part of their body, generates a genuine fear response to protect what it now considers to be part of the self. It's a visceral demonstration of how our sense of self is not fixed in our physical boundaries, but is constantly negotiated by our predictive brain based on the information it receives. But the rubber hand illusion is more than just a fascinating parlour trick. It opens a window into understanding conditions like phantom limb pain, where people continue to feel sensations in limbs that are no longer there. It helps explain how people can learn to control prosthetic limbs, gradually incorporating artificial devices into their sense of self through the same predictive processes that create the rubber hand illusion. The illusion also reveals the social nature of our bodily experience. Researchers have found that the rubber hand illusion works more effectively when the rubber hand matches the participant's own skin tone. It fails when there's too great a disconnect between the fake hand and the person's own body image. This suggests that our sense of bodily ownership is influenced not just by immediate sensory information, but by our deeper sense of identity and belonging. Even more remarkably, the rubber hand illusion can extend beyond individual body parts to encompass entire bodies. In virtual reality environments, people can be made to feel that they inhabit bodies of different shapes, sizes, or even different species. The brain's predictive machinery is flexible enough to adjust its body model, based on the new patterns of sensory correlation it encounters. These experiences can have lasting effects on self-perception and behaviour, suggesting that our sense of bodily self is far more fluid than we typically imagine. The implications extend into our understanding of empathy and social connection. When your brain's model of your body can so easily expand to include a rubber hand, it suggests that the boundaries between self and other might also be more permeable than we think. Perhaps our ability to understand and connect with others stems partly from the same predictive processes that allow us to experience ownership over artificial limbs. As you consider this, you might become aware of your own hands in a new way. Right now, your brain is maintaining its prediction of where your hands are, what they're touching, how they're positioned in space. This sense of ownership, this feeling that these hands belong to you, is not a given. It's an ongoing achievement of your predictive brain, constantly updated based on the streams of sensory information flowing from your body. The rubber hand illusion reminds us that even our most basic sense of self is, in a very real sense, a beautiful fiction created by our guessing brain. Deep within your brain, nestled in regions responsible for movement and sensation, lies a discovery that has revolutionized our understanding of empathy, learning, and human connection. These are the mirror neurons, brain cells that fire not only when you perform an action, but also when you watch someone else perform the same action. They create a bridge between minds, allowing your brain to use its own predictive machinery to understand and anticipate the actions of others. Imagine watching someone reach for a cup of coffee. As their hand moves toward the cup, specific neurons in your brain begin firing, the same neurons that would activate if you were reaching for the cup yourself. Your brain, in a sense, is internally rehearsing their action, using its own motor predictions to understand their intentions. This neural mimicry happens automatically, below the threshold of consciousness, creating a foundation for social understanding that goes far deeper than mere observation. The discovery of mirror neurons began in the 1990s when researchers studying macaque monkeys noticed something unexpected. They had implanted electrodes in the monkeys' brains to monitor neurons involved in hand movements. During a break in the experiment, one researcher reached for his lunch, and the monitoring equipment suddenly came alive with activity. The monkey's brain was responding to the researcher's hand movement as if the monkey itself were reaching for food. This accidental discovery opened up an entirely new understanding of how brains connect with each other. Mirror neurons suggest that your ability to understand others isn't based primarily on intellectual analysis or learned rules about behavior. Instead, it's grounded in a direct neural simulation. Your brain literally recreates others' actions within its own predictive framework, allowing you to understand not just what they're doing, but why they're doing it. When you watch someone lift a milk carton that turns out to be surprisingly light, causing them to overshoot the movement, you might wince or feel a sympathetic surprise. This happens because your mirror neurons are using your own predictive model of how heavy milk cartons should be. When the observed action violates that prediction, your brain experiences something akin to the prediction error the other person is actually feeling. You're not just watching their experience; in a neural sense, you're partially sharing it. This neural sharing extends beyond simple actions to emotions and sensations. When you see someone in pain, specific brain regions that process your own pain become active. When you watch someone being touched, your own touch processing areas respond. Your brain's predictive machinery doesn't just model your own future states, it creates approximate models of other people's states as well, using the same neural architecture that generates your own experiences. The implications for human connection are profound. Your capacity for empathy, your ability to learn by watching others, your instinctive understanding of social situations, all of these may be grounded in the predictive mirror neuron system. When you watch a skilled pianist play a complex piece, your mirror neurons fire in patterns that partially match what the pianist's brain is doing. This neural mimicry may be part of how you learn new skills, how you understand others' expertise, and how cultural knowledge passes from one generation to the next. But mirror neurons also reveal something deeper about the nature of consciousness and selfhood. If your brain is constantly creating internal simulations of other people's actions and experiences, where exactly is the boundary between self and other? The mirror neuron system suggests that this boundary is far more porous than we typically imagine. Your sense of being an isolated individual, separate from the world around you, may be just another story your brain tells, a useful fiction that helps organize experience but doesn't reflect a deeper metaphysical truth. Consider how this plays out in social situations. When you're in a conversation with someone, your mirror neurons are continuously active, creating ongoing predictions about their emotional states, their intentions, their likely next words or actions. You're not just passively receiving information about them, you're actively modeling their internal experience using your own predictive machinery. This creates a kind of neural dialogue, a constant exchange of predictions and confirmations that forms the foundation of human social interaction. The mirror neuron system also helps explain phenomena like emotional contagion, why moods and feelings seem to spread through groups of people. When you're around someone who's anxious or excited, your mirror neurons may be picking up subtle cues about their internal state, and partially recreating those states within your own brain. Your predictive system, designed to model and anticipate the behavior of others, ends up sharing their emotional reality to some degree. As you think about this, you might notice how your own understanding of others feels different than purely intellectual analysis. When you watch someone struggle with a difficult task, Your understanding of their frustration feels immediate and embodied, not abstract. This is your mirror neuron system at work, using your brain's predictive machinery to create a partial simulation of their experience. In a very real sense, your understanding of others is grounded in your brain's ability to guess not just your own future states, but theirs as well. As we near the end of our gentle journey through the mysteries of your predictive brain, we encounter perhaps the deepest question of all. What is it like to be you? Right now, as you read these words, there's something it feels like to be you. A particular quality of experience, a unique perspective on the world that seems to exist nowhere else in the universe. This inner experience, this sense of being a conscious observer looking out at reality, is what philosophers call consciousness, and it presents what may be the hardest problem your brain has to solve. Unlike the problems we've explored so far, how your brain predicts visual scenes, fills in blind spots, or creates a sense of bodily ownership, consciousness seems to involve something more than just information processing. It's not just that your brain predicts and processes information, it's that there's something it feels like for this processing to happen. There's a subjective, first-person quality to your experience that seems to go beyond the mechanical operation of neural circuits. Consider the simple experience of seeing the colour red. Your brain processes wavelengths of light, compares them to stored patterns, makes predictions about the objects that might be causing these light patterns. But alongside all this neural computation, there's also the subjective experience of redness, the particular quale, as philosophers call it, that makes red feel the way it does to you. This felt quality of experience seems to be something over and above the information processing, something that emerges from but cannot be fully explained by the predictive mechanisms we've been exploring. Some neuroscientists and philosophers argue that consciousness is simply what complex information processing feels like from the inside. On this view, your sense of being a conscious observer is simply the subjective aspect of your brain's predictive machinery at work. When your brain creates models of the world and of itself, the experience of consciousness emerges naturally from this self-modeling process. You feel conscious because your brain includes itself in its predictive models, creating a kind of internal observer that monitors and reflects on its own processes. This perspective suggests that consciousness might not be as mysterious as it initially appears. Just as your brain creates compelling illusions about colour, motion, and bodily ownership, it might also create the illusion of being a unified conscious self looking out at the world. The sense of being a continuous experiencing subject might be another story your predictive brain tells, another useful fiction that helps organise the massive amount of information processing happening in your neural networks. But others argue that consciousness presents a fundamentally different kind of problem. No matter how completely we understand the neural mechanisms of prediction, attention, memory, and behavioural control, they claim we'll still be left with the mystery of why there's anything it feels like to have these processes occurring. The subjective, experiential aspect of consciousness seems to resist explanation in purely physical terms, leading some to suggest that consciousness might involve aspects of reality that go beyond current scientific understanding. Your predictive brain plays a central role in creating your conscious experience, but it may not be the whole story. The constant stream of predictions, the ongoing updates to your models of the world and self, the integration of sensory information with prior expectations. All of these processes contribute to the rich, unified experience of being you. But whether they fully explain that experience, or whether something additional is needed, remains one of the deepest open questions in science and philosophy. What we do know is that consciousness and prediction are intimately connected. Your sense of experiencing a present moment is largely constructed from your brain's predictions about what should be happening right now. Your feeling of being an agent who makes decisions and controls actions emerges from predictive processes that model your own intentions and their likely consequences. Even your sense of having a continuous identity over time depends on predictive mechanisms that link past experiences with anticipated futures. In some ways, consciousness might be the ultimate prediction problem. Your brain doesn't just predict what will happen in the external world, it predicts what it will be like to be you in various future scenarios. This capacity for self-prediction, for modelling your own future experiences and emotional states, may be a crucial component of what makes consciousness feel the way it does. You experience yourself as a conscious being partly because your brain is constantly generating predictions about what it will be like to be you. As you contemplate these ideas, you might notice the strange recursiveness of consciousness. You're using your conscious mind to think about consciousness itself, employing the very predictive processes we've been discussing to understand how those processes create your sense of being an experiencing subject. Your brain is modelling itself, creating predictions about its own predictive capabilities. It's a beautiful, dizzying loop that captures something essential about what it means to be a conscious creature in a world your brain is constantly guessing about. Perhaps the deepest insight from our exploration is that consciousness, like so many other aspects of your experience, might not be something you simply have. It might be something your brain continuously creates through its predictive processes. Every moment your brain is weaving together sensory information, memories, predictions, and self-models to create the unified experience of being you. Consciousness isn't a thing or a place in the brain. It's an ongoing process, a dynamic story your predictive brain tells itself about what it's like to be itself. As we drift deeper into this gentle exploration of how our minds work, let's take a moment to consider what lies ahead in our understanding of consciousness and perception. The researchers who dedicate their lives to unraveling these mysteries are making discoveries that would have seemed like science fiction just a few decades ago. Picture, if you will, the laboratories where scientists are using artificial intelligence to peer into the very essence of how brains predict and process information. In 2024, researchers created something called Brain GPT, an artificial intelligence trained specifically on neuroscience literature. What they discovered was both humbling and extraordinary. This AI could predict the outcomes of brain research experiments better than human experts could. It's as if we've created a digital mind that can think about thinking itself. This isn't just an academic curiosity. These AI systems are helping us understand that the principles underlying how our brains work, prediction, pattern recognition, and error correction, are so fundamental that they emerge naturally in any system trying to make sense of complex information. Your brain and these artificial minds are, in essence, solving the same puzzle: how to navigate uncertainty in a world full of incomplete information. Think about this gently for a moment. When you're lying in bed tonight, listening to the sounds outside your window, your brain is doing something remarkably similar to what these advanced AI systems do. You're both trying to predict what comes next, both filling in gaps in information, both creating coherent stories from fragments of data. The difference is that you've been doing this for your entire life without even realizing it. Scientists are also discovering new ways that our brains distinguish between imagination and reality. Recent research has identified specific neural mechanisms that help us know the difference between what we're actually seeing and what we're merely thinking about. These discoveries are shedding light on conditions where this boundary becomes blurred, helping us understand everything from hallucinations to the vivid experiences we have in dreams. One of the most fascinating areas of research involves something called event segmentation theory. This suggests that our brains are constantly breaking down the continuous stream of experience into meaningful chunks or events. Right now, as you read these words, your brain is deciding where one moment ends and another begins. It's creating the structure of your experience moment by moment, like an invisible editor cutting scenes in the movie of your life. Researchers have found that people who are better at this kind of event segmentation tend to have better memories and clearer thinking. It's as if some brains are more skilled at organizing reality into meaningful narratives. This research is opening doors to helping people with memory problems and attention difficulties, offering hope for better treatments and therapies. But perhaps the most profound discoveries are coming from studies that combine brain imaging with virtual reality. Scientists can now create controlled environments where they can manipulate what people experience while watching exactly how their brains respond. They're discovering that the line between perception and imagination is much blurrier than we ever thought possible. In one remarkable study, researchers found that when people were asked to imagine themselves in different virtual environments, their brains showed patterns of activity nearly identical to those seen when they were actually in those environments. Your brain, it seems, doesn't always know the difference between a vividly imagined experience and a real one. This has profound implications for understanding everything, from trauma recovery to learning and creativity. These discoveries are also changing how we think about consciousness itself. Instead of consciousness being some mysterious property that emerges from brain activity, researchers are beginning to see it as something more like a sophisticated prediction system. Your conscious experience might be your brain's best guess about what's happening right now, constantly updated and refined based on incoming information. This perspective is both humbling and liberating. Humbling because it suggests that our sense of being in direct contact with reality is, in many ways, an illusion, but liberating because it explains why humans are so adaptable, so creative, so capable of learning and growing throughout our lives. We're not passive receivers of information, we're active constructors of our own experience. Now that we understand how our brains are constantly predicting and constructing our reality, how do we live with this knowledge? How do we navigate a world where our perceptions might not always match what's actually happening around us? First, let's embrace the wonder of it all. Your brain is performing an incredible feat every moment of every day. Right now, as you process these words, your visual system is predicting what comes next in each sentence. Your auditory system is filtering out background noises while staying alert for important sounds, and your body is maintaining its balance and temperature without any conscious effort from you. You're a walking, breathing prediction machine of extraordinary sophistication. Understanding this can actually make daily life more peaceful. When you find yourself disagreeing with someone about what happened in a shared experience, remember that you might literally have perceived different things. Your brains, with their different histories and expectations, may have constructed slightly different versions of reality from the same events. This doesn't mean truth doesn't exist, but it does mean that human perception is more flexible and subjective than we often assume. This knowledge can help us be more compassionate with others and more curious about our own assumptions. When someone sees a situation differently than you do, they're not necessarily being difficult or dishonest. They might be experiencing a genuinely different version of reality based on their brain's predictions and past experiences. Consider how this applies to memory. We now know that every time you remember something, you're not playing back a recording. You're reconstructing the memory based on fragments and your current knowledge and beliefs. This means that two people can have genuinely different memories of the same event, and both can be telling their truth as they remember it. This isn't cause for despair about the nature of truth, but rather an invitation to hold our perceptions more lightly. We can be confident in our experiences while remaining open to the possibility that others have experienced something different, or that we might discover new information that changes our understanding. In practical terms, this means we can become better learners and more effective problem solvers by actively seeking out perspectives that challenge our predictions. When we encounter information that doesn't match our expectations, instead of immediately dismissing it, we can pause and consider whether there might be something valuable to learn. This predictive nature of our brains also explains why habits are so powerful and why change can be difficult. Your brain becomes very good at predicting what will happen based on established patterns. When you try to change a habit, you're essentially asking your brain to update its prediction model, which takes time and conscious effort. But understanding this process can make change easier. Instead of fighting against your brain's predictions, you can work with them. You can consciously expose yourself to new experiences and information that gradually update your brain's models. You can practice mindfulness, which helps you notice when your brain is making automatic predictions and gives you space to choose whether to follow them. The research on our predictive brains also offers insights into why we sometimes feel anxious or depressed. If your brain is constantly predicting negative outcomes based on past experiences, you might find yourself living in a world that feels more dangerous or hopeless than it actually is. Understanding this can be the first step toward changing those predictions through therapy, meditation, or simply exposing yourself to more positive experiences. Living with a predictive brain also means accepting that uncertainty is a fundamental part of human experience. Your brain is constantly making its best guesses about what's happening and what will happen next, but these are always guesses, never certainties. Instead of this being a source of anxiety, it can be a source of freedom and possibility. If reality is partially constructed by your predictions, then changing your predictions can, in some real sense, change your reality. This doesn't mean you can simply think your way out of difficult circumstances, but it does mean that your mental models and expectations play a larger role in shaping your experience than you might have realized. By becoming aware of these processes, you gain more agency over your own perceptions and reactions. Consider how this applies to learning. When you're struggling to understand something new, your brain is working to build new prediction models. The confusion you feel is actually your brain recognizing that its current models aren't working well. Instead of being frustrated by this confusion, you can see it as a sign that learning is happening. Your brain is in the process of updating its understanding. This perspective can make us more patient with ourselves and others during learning processes. When a child is learning to read, or when you're learning a new skill, the mistakes and confusion aren't signs of failure. They're signs that the brain's prediction system is recalibrating itself. As we near the end of our gentle journey together, let's take a moment to appreciate the profound mystery of what it means to be human in light of everything we've discovered about our predictive brains. We've learned that the reality you experience is in many ways a construction. Your brain takes fragments of information from your senses and weaves them together with memories, expectations, and predictions to create the rich, coherent experience of being you in the world. This might sound like it diminishes the magic of consciousness, but I would argue it does exactly the opposite. Think about it this way. Every sunset you've ever enjoyed, every face you've loved, every piece of music that moved you to tears, all of these experiences were created by the incredible information processing system inside your skull. Your brain didn't just passively receive these experiences, it actively constructed them, painting them with meaning and emotion in ways that are unique to you. The fact that your brain fills in your blind spot so seamlessly that you never notice it, the way it predicts the path of a flying ball so you can catch it, the manner in which it constructs the experience of colour from wavelengths of light. These aren't flaws or limitations. They're features of a system so sophisticated that we're only beginning to understand how it works. And yet, for all our scientific understanding, the deepest questions about consciousness remain beautifully mysterious. We can map brain activity and identify neural correlates of different mental states, but we still don't fully understand how subjective experience arises from objective neural processes. Why does it feel like something to be you? Why do you have inner experiences at all? This is what philosophers call the hard problem of consciousness, and it remains one of the deepest puzzles in science. But rather than being frustrated by this mystery, we can find comfort in it. There's something wonderful about the fact that consciousness, the very thing that makes us human, retains its sense of wonder, even as we learn more about how it works. Your predictive brain is not just a biological computer processing information. It's the source of your creativity, your capacity for love, your ability to find meaning in existence. When you read a poem and feel moved, when you solve a problem that has been puzzling you, when you comfort a friend in distress, these are all expressions of your brain's remarkable ability to predict, model, and construct rich, meaningful experiences. We've also seen how our individual differences in perception and memory make each person's reality genuinely unique. The way you see colours, the memories you form, the assumptions your brain makes, all of these are shaped by your particular history and biology. This means that each human consciousness is, in some sense, experiencing a slightly different universe. This diversity of human experience is not a bug, it's a feature. It's what makes human culture so rich and varied. It's why art moves us, why stories matter, why different perspectives can teach us things we could never discover on our own. Your brain's particular way of constructing reality contributes something unique to the human tapestry. Understanding our predictive brains also gives us a deeper appreciation for the courage it takes to be human. Every day you navigate uncertainty with incomplete information. You make decisions, form relationships, and create meaning despite living in a world where your perceptions might not perfectly match reality. This isn't a failure of human cognition. It's the essence of what makes us human. We are beings who can wonder about our own wondering, who can study our own consciousness, who can discover the mechanisms behind our own perceptions. We are predictive systems that have become aware of their own predictions. In the entire history of the universe, as far as we know, this kind of self-aware prediction machine has emerged only recently, only here on Earth, only in creatures like us. This realization can fill us with both humility and awe. Humility because we now understand how much of our experience is constructed rather than directly perceived. or because the construction process is so sophisticated, so beautiful, so capable of creating meaning and purpose and joy. As you go through your days after our journey together ends, you might find yourself noticing these processes more. You might catch your brain making predictions, filling in gaps, constructing your experience moment by moment. Instead of being unsettling, I hope this becomes a source of wonder. You're witnessing the miracle of consciousness in action. Remember that your brain's tendency to predict and construct reality is not something to overcome or fix. It's something to appreciate and work with. When you're feeling stuck, you can remember that your brain is always capable of updating its models and forming new predictions. When you're facing uncertainty, you can take comfort in knowing that uncertainty is the natural state for predictive systems like us. We are all fellow travellers in this strange and wonderful business of being conscious, predictive systems trying to make sense of our world. Every person you meet is carrying their own constructed reality, their own set of predictions and assumptions, their own beautiful and complex way of experiencing existence. This understanding can make us more patient with ourselves and others. It can help us approach disagreements with curiosity rather than frustration. It can remind us that learning and growth are always possible because our brains are always capable of forming new predictions. Most importantly, it can help us appreciate the profound mystery and beauty of being human. You're not just a passive observer of reality. You're an active participant in creating your experience of being alive. Your consciousness is not just a window onto the world. It's a creative process that brings meaning and richness into existence. And thank you for staying with me through this peaceful journey into Is the Brain Just Guessing the World Around You? If you found this story calming or inspiring, I'd be so grateful if you could like this video, share it with others, and subscribe to our channel. It truly helps us grow this little world of wonder. And if you enjoy drifting into sleep with stories like this, feel free to explore the rest of our channel. There's so much more waiting for you. Until next time, take care and rest well. Sweet dreams, and may your beautiful predictive brain continue to create moments of wonder and peace for you.